I literally got the worst problem.
Shut up. Okay, in problem A, you have to show that the total charge Q in the region of radius A is this, right? And then, so Q is equal to the integral of rho times dV, the derivative of volume, of volume. And then dV can be turned into 4 pi r squared dr. And then the limits are A to 0 because it asks you for the stuff within the radius A. Thanks. And then it's already given that rho is equal to beta r. And then
What time is it?
So you just turn that into integral from A to 0 of 4 pi beta r squared. And then you just solve for the integrand, and you get this times 4 pi beta, 4 pi beta, and then this is just equal to pi beta pi a4, which is what we wanted. Alright, so that's how you do problem A. Okay, now for part B, you just have to use the equation E is equal to Q over 4 pi epsilon naught r squared. And then this is, now you already got Q from part A, right? And you just sub it in. And then it's just pi beta a squared, since the pi's cancel out, over 4 epsilon naught r squared. And well, that's the first part of B. Okay, so this is for the second part of B, this is for when R is equal to A, right? So this is the situation when R is equal to A. In this one you can model, and for the first part you can model it like this because you can model it like a point charge because it's outside of the sphere. And for this one, R is equal to A, so E equals oh, for this one, for the first part, I meant A to the fourth, not A to the second. My apologies. And then, so for this one, E is equal to beta A to the fourth over 4 epsilon naught r squared. So you take the answer you got from the first part, and you just sub in A. So it equals beta A to the fourth over 4 epsilon naught A squared, and then this cancels out and this becomes a 2. And so it's just equal to beta A squared over 4 epsilon naught. Alright, and then for part 3, it's within the sphere, so now you have to use Gauss's law. And so you just do E ds is equal to Q over epsilon naught. And then you know E ds is equal to, since it's a sphere, it's equal to E 4 pi r squared. And then to find the Q, you need to use an integral again. So you do 1 over epsilon naught is times the integral from r to 0 of the charge density times dV. And then this is equal to 4 pi over epsilon naught r, the integral from r to 0 of the charge density times r squared dr. And then once again you sub in using the formula rho is equal to beta r, and then you get 4 pi over epsilon naught of r beta r with the cube dr, and then that's just equal to 4 equal to beta r squared over 4 epsilon. Alright, for the next part, you are asked to find the velocity. No, when is yeah, whatever that is. Alright, so you're asked to find the electric potential. And so the electric potential when R is equal to A, it's just equal to V is equal to Q over 4 pi epsilon naught R. Because that's just the basic equation. It can be modeled as a point charge because it's outside of the sphere. And then this is equal to, you just plug in Q, and then you just get beta pi A to the 4th over 4 epsilon naught pi R, and then the pi's can cancel out, and then R is equal to A, and so this just equals beta A to the 3rd over 4 epsilon naught. And then for part 2, you just do V is equal to, since you want the voltage when R is equal to 0, you can just do V when R is equal to 0 is equal to negative 0 to A E cross product dot product dr plus V when R is equal to A. And so this is equal to A naught this thing.
No way.
And then you just solve this integral, and then you get B A to the 3rd over 12 epsilon naught plus B A to the 3rd. You just put. What the heck? What the hell? What? And then you just get I am sorry, students. There are some technical difficulties. Okay, you get this part from your answer to part 1, and then you just get this answer. We're done.
Dude, what was that?
How come you had to do this like 3